Hello, and welcome to episode number 16 of the AwesomeAlgo podcast. And today's guest is Joe Polny. He is a software engineer at Algorand Foundation. We are here to talk about his little baby project called, and I hope I'm not going to mess this up, TEALScript. The funny thing for the listeners there, I initially confused it was a different language. But this is exactly the topic I would like to discuss, because if you thought we were done with transpilers that write a convenient language into Teal, you're wrong. We actually have another exciting episode to talk about tooling like this. So to provide a little agenda about what this episode is going to be about, basically, we're going to talk about TealScript, and TealScript is essentially a high-level transpilation language. You may have heard about Tealish, you may have heard about PyTEAL. It's a very similar premise in this regard. However, the big difference is that I would say it's very, very, very close to the stack that majority of the app developers are using, which is JavaScript, TypeScript. Most of those things rely on, eventually you would need a front end, and JavaScript is really dominating in this particular space. So I think Joe did a very interesting bet in this regard on trying to write a language for TypeScript, basically, which I suppose can make an entire development flow very, very simple and straightforward. And even I could imagine some folks having a single code base for everything. But without further ado, let's dive into this episode. I would like to start, as usual, with the biography. So, Joe, if we could start a little bit with your academic background and some decision making behind choosing this magical field of computer science, software engineering that is unfortunately being destroyed by AI these days. But yeah, let's start with that one.
Yeah. So so in terms of like my academic background, so I graduated high school in 2016. And then right after there, went for my undergraduate's degree at Wentworth Institute of Technology and got a bachelor's of science in computer engineering. So for those that aren't aware, computer science is mostly focused on like the software theoretical side of things. And computer engineering is a little bit more of basically computer science plus electrical engineering. So you're working more kind of low level, working with the hardware, which ended up actually really helping me out in my Algorand, career working with these low-level languages like Teal. But yeah, so I got my undergraduate in computer engineering, and prior to that, during that, and now after that, computer like technology, I guess in general, has always been a big passion of mine, and I always knew, even from a very young age, that I wanted to go somewhere in the technology field. I think like a lot of people, especially my age, the initial interest was video games. So I initially thought I wanted to be a game developer. But as time went on, the game kind of became meta for me. And it was, rather than building a computer to play games, I was building a computer for the sake of building a computer and learning about the hardware and how these different components work and how they fit together. And that's really when I decided that I'm really interested, to pursue this as a career. Let me study computer engineering, where I can get a kind of best of both worlds in terms of hardware and software. And so that's exactly what computer engineering allowed me to do. And yeah, very, very happy that I ended up going that path. And it's a path that I recommend if you're someone that's just generally interested in technology. I think a lot of people just think of computer science as the thing to study, but there's computer engineering, and then also like more specific things like cybersecurity and stuff. So for anyone watching that is kind of thinking about that, definitely take a look at all your options, because computer science isn't the only field to go in for tech related stuff.
Absolutely. And I would like to point out also a nice similarity with some backgrounds of my other guests from Algorand, which is Cosimo. I believe Cosimo started as a control or electrical engineer, which is, I suppose, is very close to computer engineering as well.
Mhm.
I could imagine you had a lot to deal with some very low-level languages, some PLC microcontrollers and things like that.
Yes. Yep.
So just for the sake of consistency, because I often ask this question to other guests, like, what was your very, very first programming language that sort of got you to the point when you were not thinking about this as a playground where you explore or learn things, but we're actually thinking about it as a tool. Like you weren't concerned about that you might not know something at the stage at which you reached this with a particular language.
Yeah, I mean, the first language that I ever first played around with, again, which is probably the same for a lot of people, is JavaScript, because you could right-click, inspect element, and change a web page, which was cool. But the first language, like, I really took serious in terms of like learning and actually going through the whole process of not just like changing code, but like designing an app and writing code would probably be C++. And really the only reason for that is because it was the first language that I had available to me in high school to take a class on. And so I've always played around with languages like JavaScript and Bash and the more like scripting kind of side of things. But I never really sat down with like a full language like C++ before this class. So in that class, it's funny because it was actually a pretty poorly run class. The teacher just said, go to tutorials point and go through all the tutorials. But that ended up working pretty well for me. And I built it's like a text-based, turn-based fighting game. And so that was my first kind of intro into software development as a like process and really understanding what it means to learn a language and think about, like class design and stuff like that. And then also kind of around the same time, I was really into, as I mentioned earlier, like one of my passions, especially early on in life, was video games. And so I was really into like the modding scene at the time. And in particular, I liked modding Call of Duty. And they used their own language called, I think it's GSC, probably stands for Game Script C or something like that. And it's very similar to C++. So those were kind of like the first two languages where I really started to, I guess, identify as a software developer. And those were the first languages where I really felt like I could start with an idea and then turn them into something, which is really cool.
Interesting. Yeah, I would also absolutely recommend C++ as a first language. I think we're certainly reaching a point at which, it's like when you have these massive language models these days that can do transpilation from any single language to any other single language, the relevance and the sort of importance of knowing something that doesn't have a lot of syntactic sugar, that shows you a lot about how underlying memory management works and things like that, becomes less and less relevant because of the fact that it's very easy to generate the code you want these days. But doesn't mean that it's not important. I think that's one of those advices that is still relevant. It's always better to have this very steep learning curve initially. It's certainly harder, right? If you pick Python or JavaScript for a high school student to learn, he's going to have some challenges. But the second he gets around it, he's going to see a lot of patterns in other languages, and it's going to be a lot more convenient when you start realizing, okay, so this is all of this syntactic sugar making my life easier now, but okay, at least I know how this works, under the hood.
I think that's true in general, not just for languages, but also like just technology in general. Like whether you're working with C++ or like a higher level language, you don't necessarily need to fully understand like how a CPU works and like what the instruction set is like. But if you do have that understanding, it can be really helpful especially like in a lot of edge cases and like in optimization, having as low level of understanding as possible ultimately helps you kind of build those higher level abstractions and make them actually like useful. And if you're able to understand them, then I think that makes you like much more effective in terms of realizing what you want to build.
Yeah, exactly. And I guess moving to the field of blockchain, What was your sort of first involvement with blockchain? And I don't know if you are a fan of term Web3 or not. It's a very controversial term, I would say, but let's call it Web3 because it's been mentioned many times in this already. So yeah, what was your sort of first fascination that got you interested in this area?
Yeah, so I mean, it really started, a couple years ago, probably like 2015, 2014 is when I first started really hearing about Bitcoin, and I just had a general interest. Like I wasn't really buying it, I wasn't mining it yet at that time, but I just thought it sounded kind of cool. And then in 2016-ish, I found out about Dogecoin. And the reason I found out about Dogecoin is because I was active on Reddit, and Dogecoin, like there's a Dogecoin tip bot, and it was just kind of part of the Reddit culture at the time. And so I kind of got this more fascination of the community aspect of crypto, and kind of understanding like with the Dogecoin tip bot, you could, write something in a Reddit comment and then see it happen on this like open blockchain. I thought that was really cool. And it's kind of funny, like my first real like entrance into the scene was there's an exploit on a Doritos website for Xbox Live codes. And so I was using that to sell Xbox Live codes for Dogecoin on Reddit. And that was kind of my first like, main entrance into this scene. And then outside of that, also like, I was young high school, middle school student. Thought it was cool that I could use my computer to make some money when I'm not playing games on it. So the mining aspect was also interesting. And then after that, it was kind of a period of I would sometimes use it to like play on like poker sites or something, but wasn't super into it. And when I say it, just like crypto in general. But then the most kind of recent bull run, like 2020, 2021, is when I started to get a little bit more interested in it, because I started hearing more about these projects like, Algorand, Cardano, Ethereum, like these smart contract platforms. And I have heard of Ethereum before, but I remember thinking, and I don't know why this article stuck out to me, but in like 2016, 2017, there's this article talking about Ethereum, and it was like this network enables Uber, but it's completely decentralized. And my initial thought was, well, that's incredibly stupid, right? Like, why would you want that? There's so many important things for these centralized entities, to exist in something like Uber. So I kind of just initially just dismissed it. But then as I started researching the technology and its use cases more recently, then I realized kind of what decentralization really means and how important like interoperability is between these decentralized networks and each other, and then these networks and our relatively centralized world, and kind of understanding all the different use cases for crypto and where it can really make the world a better place, in short. And I think that's ultimately what attracted me to Algorand. So around this time in 2021, I was researching these cryptos, and as a developer, like I wanted to get my hands on and actually write smart contracts and see what it was all about. So I was researching a bunch of different platforms. Actually started Cardano was like my first coin that I was really like buying just as a sole investment. Probably partly because of Charles Hoskinson, right? And then also just because I thought Cardano was it seemed more practical than things like Ethereum, and they're also doing interesting things in like Ethiopia in terms of like real world usage. So that sort of stuff interested me. But as I started to really get into the technical side of things, that's when I landed on Algorand. And the thing, honestly, that like if I had to pick one thing that really impressed me about Algorand, I was going to the documentation and being able to click through all the different languages and seeing how you can do the same thing in all the different SDKs. And I just thought the overall documentation experience was really good. And then I started, researching a little bit more about Silvio and our consensus and stuff like that. And it kind of was clear to me, like, like when I read that Uber article, I was like, this doesn't apply to the real world. And then now, in 2021 at the time, I was reading about this Algorand technology. I was like, wow, this can apply to the real world. And that's really what got me into the more technical side of things. So I was just starting to build smart contracts, and then I was active in the Algorand Discord, which if you're a developer and not in it, discord.gg/Algorand, definitely join it. But through that just general curiosity, where at the time I was working in the defense industry, just my free time was learning about Algorand. I just developing smart contracts, and as I got to know more and more about it, I gained more and more interest, and then it eventually led to a job opportunity. So that's how I ended up here in this space.
Awesome. That's certainly a very interesting journey that you had, and I could see how some listeners can derive the difference between a person with a computer science background and a person with a computer engineering background, because you certainly have a lot more applied approaches, hands-on approaches, and sort of practical things. And that remark you made about Uber, which is ironically something that one person from SEC mentioned a couple of years ago, but as you may have heard today, there have been some changes in the agenda. So I guess after you got into the Algorand ecosystem, there was some period of you aggregating knowledge, trying to understand how a lot of different moving parts in the system are working. I would really like to make a little segue into TEALScript itself, but I guess just to set the stage, what was the main sort of pain points for yourself that became one of the things that motivated you to eventually create something like TEALScript?
Yeah. So at the time, like the main language was PyTEAL. We didn't yet have Beaker, so it was just using the PyTEAL library with Python to generate smart contracts.
And sorry, this is, I suppose, 2021.
Yeah, so this was like December 2021. So very late 2021 is when I first started getting started with Algorand, and I was using PyTEAL. And one of the things that also I found attractive about Algorand was that, you can use Python. But very quickly into my PyTEAL journey, I learned that you're still using Python, but the way you think and the code that you write is not really Pythonic. And I don't think that's necessarily like a bad thing, but it also means that the learning curve is a little bit steeper than I initially anticipated.
I think you just made Fergal from Tinyman happy by saying
yeah. So and I'll talk about this in a bit, but I think me and Fergal have very, very similar like overall views of where the space and languages and stuff need to go. But yeah, so working with PyTEAL, I found it kind of frustrating that there's these things I knew how to do in Python, but I didn't know how to do in PyTEAL. And I think that's pretty common whenever you're working with like a new framework or DSO or whatever. But it felt like, just like intuitively to me, it felt like I could imagine this being done in just native Python syntax, right? And so like there's like one thing in particular that really bothered me is that anytime you use an integer or a string, on chain in your PyTEAL code, you always have to like instantiate the int the bytes class.
The bytes thing, yeah.
Yeah, and so this is super simple. It's not like a hard concept or anything, but as a developer, it's just super annoying to keep having to type that. And if you forget to type it, I think the error has since improved, but at the time, the error was absolutely terrible. And it was just small things like that that really bother me. And I think in this space, it's really that initial dev UX, I think, is really important for adoption, because I think a lot of people in this space, there are so many different smart contract platforms, so many different languages. And if you have one bad experience with one language, then you'll probably just go on to the next. A lot of people don't necessarily like spend the time learning about the low level details of consensus or how the VM works. They just care about what does it look like to build on this chain. But I think at the time it really wasn't that great of an experience. I think now it's gotten better with things like Beaker, and then PyTEAL recently got like source mapping, so there's definitely steps being made to make like the PyTEAL experience better. But ultimately, I think not just with Algorand, but for if you want to, if you're traditional Web 2 dev and you want to come into this, Web 3 space, you have to learn a new language, which, as you mentioned, like today, it's not really a big deal. And I think, especially if you're like a senior developer, you kind of learn all languages are more or less the same. It's just a matter of, how you do different things, like how you write different things, but the way you think is mostly the same. So it's not like at a face level, it's not a big deal. But when you compound that with the fact that smart contract development is so different than like regular Web 2 development in terms of you have to think about, data design and like your overall architecture, and you have to think about optimizations in ways
There's a lot more immutability to the things you write.
Exactly.
Yeah.
Right. Yeah. And I think that's also one of the areas where coming from the low level, computer engineering background helped, is that so like in school and then in my, career before Algorand, I was working with embedded systems where I had to think about, constraints and, read-only memory and stuff like this. But that's something that a lot of devs, especially if you're just like traditional Web 2 JavaScript dev, that you're not thinking about. And so compounding the new language plus an entirely new mindset of how I have to think about program design adds a lot of friction. And so, my initial, solution to this problem wasn't actually TealScript. It was a Ruby-based DSL called TealRB. And from that, what I actually started with, I basically envisioned a language that was basically raw teal and then had some, syntax sugar and abstraction on top of it. So you could write raw teal inline, but then also have like more abstract, kind of like object-oriented classes and stuff like that as well. I ultimately moved away from that project for two reasons. Ruby doesn't have a really great typing system, and it doesn't have great IDE support, which I feel like those are two really important things for development, modern development, especially for smart contracts. And then also, it felt like just Tealish did what I wanted to do, just way better. And I think Tealish is like an amazing language, and I just didn't see much value in me trying to, directly compete in that same space. I don't even know if compete is the right word, but like try to oversaturate that space, where I would still say Tealish is relatively low, maybe like mid-level language. And so with TealRB, I started from Teal and wanted to add abstractions on top of that. With TealScript, my goal was I wanted to take this high-level language that already existed and work my way down into Teal. So really the main goal of TealScript is making it as familiar as possible to, traditional Web 2 developers that in particular are used to JavaScript and TypeScript. So, my first iteration was I before I even wrote the compiler or anything, I just wrote what I wanted a smart contract to look like in TypeScript and then worked back, okay, I have this code. How do I turn this into Teal? And that was kind of the mindset where I think my earlier language, TealRB, and then something like Tealish starts more at the primitive Teal opcode level, builds up from there. I'm kind of taking the opposite approach of starting at the high level language and then building down. And really the goal, like I said, to make it familiar, but also like you get all these benefits of TypeScript out of the box is supported by VS Code. You don't need any extensions. And so TealScript is completely compatible or completely valid TypeScript code. So your IDE will tell you if you, need an account here, but you actually have an address or like something like that. And so not having to do all that like extraneous developer tooling, like things like linters and code formatters and testing frameworks, like those all already exist, right? So it's nice to be able to leverage those. And like you said kind of earlier, you can integrate that with already existing code bases. So if you have a TypeScript code base where you're developing your front end for your dApp, you can have TealScript in the same directory structure using the same, ESLint config that has all the same formatting, and it just makes it a little bit easier to work with. And I mean, there are other couple benefits of TealScript that I'm sure we'll get into a bit later, but that's kind of the main goal, is just to make it as familiar as possible to developers, because I think that's ultimately the biggest roadblock for any blockchain development. And I think it's the reason why why does every developer that you talk to pretty much in this space first start with Solidity? It's because there's a ton of resources on Solidity, ton of example code, and especially now in the age of AI, like all these LLMs, they're familiar with Solidity, right? They can help you with Solidity. And so how do you, like PyTEAL and Teal, they can't really compete with that. They're just not mature enough. But if you take advantage of something that already exists, like TypeScript, then you kind of bake some of that maturity into the ecosystem. And then now, like I've had ChatGPT like analyze TealScript contracts for me and help me write them. And being able to integrate with existing tools like that, I think is really important, especially now with AI stuff. So yeah, there's a lot of interesting angles to it, but it's mostly just about being as familiar as possible.
I see, but I think you made a great differentiation in between Tealish and TealScript. We'll certainly get to it later. And another thing is that thanks for reminding about the Ruby thing that you did. I guess it's safe to say that they can move it to the archive now if you moved it to an archive state.
Yes,
the AwesomeAlgo.
It has since been archived.
But absolutely agree with your points. We are, once again, in a very, very, I would say, small industry, right? 200,000-300,000 engineers in total, hundreds of projects. Everyone is doing their own language, framework, paradigm, whatever. If you want to get developers, if you want to get adoption, developer experience should be out of the question. Like it absolutely has to be easy. It has to be logical. It has to make sense. It needs to be very easy to set up and just fit into whatever device ID setup that you have for your ideal development experience. And tapping into a language like TypeScript in this case is, I would say, certainly gives you a lot of interesting angles in regards to adoption. But let's talk about features. What would you say is, aside from the fact that you can basically do smart contracts in the world TypeScript, what would you say as an overview of like key language features of TealScript? What makes it unique in comparison? And for comparison, let's just use PyTEAL, because I mean we could say Beaker, right? But Beaker is just, one could say, is just a set of extra abstractions on top of PyTEAL. So let's say PyTEAL and Tealish.
Right. Yeah. So, the main thing I wanted to do with TealScript is provide like I said, provide a familiar environment for developers. So one of the big focuses for me has been full ABI support. And so when I say that, I mean, first, like the standardized way of routing different methods in a contract. So thinking about how to define methods in TealScript and how to handle different scenarios in those methods. So like, for example, in Beaker, you have these decorators that can point to different, like create, update, delete, different on-completes and different actions. And I follow a very similar pattern for TealScript, but for the methods itself, they're just defined like regular TypeScript methods. So if you wanted to define a publicly callable method that was exposed in the ABI, you would just write it like a TypeScript method, provide your argument types, your return type, and then that'll automatically get exported into the ABI JSON. But similarly, you could also have private methods. So these are methods, much like in regular TypeScript, are not publicly callable. They're just internal subroutines that the underlying TEAL will utilize, for optimizations. And to write these, you just, write the private keyword. So on the method side of things, that was pretty much my number one goal, was just writing methods in a native way in TypeScript so that it's supported by the API. And then kind of the other side of the API is the typing system. So TealScript supports pretty much the full range of API types. So for comparison, so PyTEAL, it supports some API types, but not all of them. And in particular, there are certain like size integers that PyTEAL doesn't support. And if you're working with like really complex like arrays or tuples, then PyTEAL can get kind of like unwieldy in terms of working with those types. And so that's one of the main things that I wanted to also really focusing on is a common pattern in traditional development as using arrays and then like loops iterating over them, like enumerable object types.
Mm-hmm.
And I think having good support for that out of the box was really important to me for TealScript. So it supports the full API spectrum, except for Booleans right now. I just haven't done the Boolean encoding, but that should be relatively straightforward. But you can write tuples and dynamic arrays and everything.
And I'm sorry to interrupt, but just one follow up on this regard. In PyTEAL, one particular thing, or in this case, I would say Beaker, if you're dealing with Beaker, that can get pretty annoying from time to time is when you have different methods. And let's say you have a subroutine and you have an ABI external method which accepts some ABI UI and 64 arguments. But then the subroutine takes the arguments of type that are imported from PyTEAL, right? And it's named identically, but it's a different import statement, basically. How do you take care of this in TealScript? Is it something that you completely hide away from user, or you still need to explicitly say, okay, from ABI, I want this particular type, but if it's not prefixed with ABI or whatever, then you're gonna basically opt in for some other primitive method.
Yeah. So, and also just a bit of a side note, like earlier you asked, like what led me to start developing, these sorts of tools. And I do want to mention also that, my role at the foundation is an engineer on the developer relations team. So one of the things that I do, as part of my job is work with new developers constantly in environments like boot camps, where some of them are just traditional Web 2 devs or completely new devs in general. And so some of the struggles I've shared are, the struggles that I've also been seeing in these environments, like time after time of teaching new developers this. At this point that you make between the kind of separation between, Beaker using API types everywhere, and then PyTEAL using the TEAL types, where it's either TEAL type bytes or TEAL types uint64, and that's all you have. Someone I did a boot camp last week, and that was one of the questions that someone had. And the problem, really the fundamental problem with PyTEAL in general, and then that eventually leads to problems like this between type kind of incompatibility, is that PyTEAL uses a mix of like Python native types and its own type checking system. So PyTEAL itself, you're constantly working with what are called expressions. And then, so like at the Python level, the type of that object is just an EXPR. And that EXPR object has a .type of method, which is its own custom method that each instantiation has a different value for. And so like type checking during the compiler is different than if you're writing a method for like a Beaker ABI method, you write ABI.uint64, and that's not an EXPR, and it's just a fundamentally different object. And so it, like you said, like when you're working between your ABI method and subroutines, then you have to do the manual encoding, decoding method calls, which is particularly annoying because you have to like instantiate it. Yeah, exactly. You have to instantiate it and dot get, dot put everywhere. And then if you forget it, you get a disgusting error message. And like, that's a really big pain point and something that I wanted to solve. And I think ultimately just because of the way PyTEAL works, and I think PyTEAL was written kind of prior when the only types you were working with were the AVM 64-bit integer or bytes. Like, I don't think it was really designed with ABI more complex types in mind. So now that you have these two different like underlying objects and having to use all these functions, it can get really confusing. It's the same for like global storage as well, which is even more confusing because like box storage and in Beaker uses ABI types, which is compatible with your method arguments, but then global and local state storage use the TEAL type. So there's a lot of conversions there, and you have to really keep track of like where is this type coming from, how is it encoded, that sort of stuff. So to answer your question, in TEALScript, it's basically all just the same, and the compiler will handle everything for you. So one of the other annoying things in particular with PyTEAL and working with the ABI is that it's very common that a developer has some method that takes in what we would commonly think of as a string, right? Some ASCII encoded sequence of bytes that represents some text, but the string type and the bytes type that you're working with in PyTEAL are fundamentally different. So you have to do things like .get or encode bytes as a string to like compare them or to like properly concat them, stuff like that. TEALScript will kind of basically do it automatically for you. So like so for those that don't know, basically the ABI string type is your ASCII, byte sequence, and then it's prefixed with the length of the string. But if you're just working in native bytes, that prefix doesn't exist. It's just your raw bytes. And so what TEALScript does, so basically as soon as it gets in a string argument, either from a log or from an input argument, or just chop off that prefix. And then that's what's actually used at the low level. And then when it needs to re-encode, like for example, when you're returning the value or when you're calling a ABI method internally, it'll know, I need to add the prefix back. And so the similar thing, applies for like UN64s as well, even though the underlying objects is the exact same for UN64s between ABI UN64 and TEAL type UN64. They're at the end of the day different representations at PyTEAL level, but in TEALScript, they're both just UN64s. There's no separation between AVM type and ABI type. They just completely compatible. And one other interesting feature that is worth mentioning as we're talking about types is that you could also do native math with wider or narrower, like smaller integers in TEALScript. So in Python or PyTEAL, if you're working with, let's say you have two uint16s and you want to add them, you can't directly you can't just write out instantiate the uint16s and then do the plus operator and work. You have to manually like ABI encode it and then use the plus operator in your sequence and everything. So it can get a little bit unwieldy. Whereas in TEALScript, all the integers at like the high level, high level language, they work the exact same. So whether you're working with uint64s, uint16, uint512, it's all, if you want to add them together, you just put a plus sign between the numbers. And even if you have like a uint16 plus a uint32, it'll automatically like convert the answer to 32 bits, and there will be a compiler warning, but it'll do a lot of that thinking that you still have to manually do in a language like PyTEAL for you. And you also mentioned Tealish as well. Tealish in terms of type support, Fergal talked a little bit about this in his Decipher talk. But basically, their main goal right now isn't full ABI type support. They do support like integers and stuff like that, but a lot of the more complex typing, so things like tuples, aren't directly supported yet in Tealish. So you have to do basically in Tealish, if you want to have a single box or global state store a bunch of different values, you have to kind of come up with your own encoding. And whereas TEALScript kind of does it all for you in accordance with the API. So really the goal is kind of just abstract, kind of as much as possible and not have the developer think about these low level things. And I will say, and a perfectly valid criticism of that approach is that we're working with smart contracts that could potentially hold millions of dollars. It's important to have low level understanding and control, which I definitely think is certainly a valid mindset to think of, but also of the belief that being able to understand the high level code is just from like a reader's perspective is just as, if not more important than being able to have low level control for the developer. So like things like language comprehension, I think is something that is really not talked about enough in this space, right? Like the whole ethos is it's decentralized, you don't have to trust anyone, but anyone interacting with a smart contract is basically trusting that that contract is doing what that person says it does.
For some, it's the code is the law. Well, if you're saying that the code is the law, then please make sure that you can, write something that other people can read.
Exactly.
Instead of making something extra preposterous that you need a language model trained with millions of dollars to understand what's going on in there. Readability is paramount. I absolutely agree with your point, and it's certainly great to hear that it's the same sentiment with Tealish as well. Just a few side questions in regards to ABI, which I guess for some folks who started developing quite early, is still something that needs to experience some refinement, and I know that there's already some great changes in the pipeline on the way. But so if I understand it correctly, you're saying that, and for the listeners out there, just to recap what you've been saying, so the way ABI is integrated is basically it's completely hidden from the user. Does this mean that by default, absolutely every contract that you write in TEALScript will be ABI compliant?
Yes, yeah, okay, exactly. Okay. So the only way to actually get to reachable code in TEALScript is to write an ABI method.
So there's no option like in Beaker where you can have like a flag in the decorator and it will become I forgot the name. It's like raw or something like that, where you basically make a non-ABI method through a decorator.
Right. Yeah. So TEALScript right now it's solely written to write ABI applications.
Okay. Got it.
So you can't like do your own like method routing or like it also doesn't support logic signatures yet. So the method routing is kind of just baked in. And so if you're writing a TEALScript contract, you need to have at least one, ABI entry point. Now, if you wanted to, you could write one method called main that takes in just some byte argument that's not ABI compliant, and then do your manual routing from there. But like the default, entry point is through an ABI method, and then kind of the way we, it tries to encourage developers to write is to write, ABI compatible methods.
Yeah, but since you're dealing with TypeScript, you're also in a unique position that doesn't really that makes you basically ignore worrying about the main criticism that ABI has at the moment, which, if I understand correctly, is basically the way foreign references are handled and things like that, when you basically need to demand an answer from your invoker of the call to the smart contract, before you actually know the answer, you're already asking for an answer, right? You need to know all the foreign references. You need to know all the box keys and things like that. But if you're dealing with something that's written in TypeScript and you hide all of this stuff nicely, writing a client that can then interact with a contract and fill out those missing gaps that will assemble the answer for an ABI call is significantly easier. Of course, you can have Beaker, which is also having something similar to this route, right? I believe Baranji is working on Beaker TS, which is allowing you to generate the code into TypeScript, building those clients basically to interact with them. So yeah, I guess like it's an interesting position to be in, because that's not like as big of an issue if you're writing something in PyTEAL, because if you did something in Python, well, in most cases you'll have to think about, okay, how do I turn this stuff into something I can put into my front end now?
Right. Yeah. And so I gotta just to touch on that a little bit. So how you mentioned Beaker TS, and for those that don't know, Beaker TS is basically a tool that auto generates front end code for you based on a contract that you've written. And how that works is a Beaker contract generates what's called the application spec. And this is kind of like, it's a JSON file that contains the API JSON. So like all your information about your methods, but also even more information like the program, like the compiled source code, the
enums, the structs that you have.
Right. Like all the type information, stuff like that. So it's a more like complete description of what your contract is and how to interact with it. And so TealScript actually is also compatible with Beaker TS. And now also like part of AlgoKit, there's AlgoKit utils, which is also able to read that app spec file. And it's actually currently being standardized. I think ARC 32 is the standard for that. So with TealScript, like you mentioned with foreign references and API types, as long as you specify that the type of your argument is an account, then that app spec and API JSON will be able to generate the client that automatically populates those foreign arrays. And I do want to also talk about one of the so you mentioned like this foreign array problem as being one of kind of the big problems with the ABI, just general dev UX. One of the other problems that I want to touch on for the ABI specifically, and that I've constantly been thinking about how I want to handle in TealScript, is that the ABI, it's the way it's written and the way types are encoded. The primary goal is really to make them as read efficient as possible, and then also to make them like as small as possible, so they're efficient over the wire. And this is really great for things like method arguments, but when you are working with like complex data types, so if you have a tuple with different arrays and dynamic arrays and all these complex types, the encoding, it's still very read efficient, but it becomes very write inefficient. And that's something that I think is particularly challenging with higher level languages, because if you're in JavaScript, you're used to just writing an array, like 5-dimensional arrays, and that's nothing, right? That's something that JavaScript can handle just fine. But if you do that in a smart contract and it just follows API encoding, you're very going to quickly run out of opcode budget. And so one of the other design goals of TealScript that I'm still constantly thinking about whether this is kind of the right path is setting up some restrictions on how people can use these sort of things to limit how easy it is to hurt yourself in your code. So for example, the API, when you encode, so let's say you're encoding a static type, so like a uint8, that's just a single byte. It just takes up a single byte in your data structure, and the compiler, whatever end client, it knows that's just that byte is the uint8. But if you have a dynamic type that could take up any number of bytes, like an array with an unfixed amount of numbers, then how do you encode that in the ABI? It's the first value is an offset in the entire data structure that points to that dynamic type. And so what this basically means is if you have a tuple with multiple dynamic types, the earlier in the tuple that an array is that you update, so let's say you make an array bigger earlier in the tuple, not only do you have to update that array and update that array's offset, you now have to update every single array that comes after it in the data structure, which can be really expensive. And so if I'm a Web 2 dev that just knows JavaScript and wants to write my first smart contract, and I'm writing an array, I'm not thinking, oh, I'm accessing this one more, therefore it needs to come, later in the array. But you kind of need to think like that if you're working with ABI types. And because TealScript has so much abstraction, I wanted to think about like, how can I protect users from doing this? And so what I did with TealScript, and this is probably the biggest difference, and I guess like incompatibility compared to other languages, that when you're writing a tuple, any dynamic type has to come at the end of the array or end of the tuple, and you're limited to 32 types. And without getting too into why, 32 and why the end, it's basically because I came up with my own algorithm using bitwise operations and some, bitwise math to update all those array values in a single operation, or all those array offsets in a single operation. So now whether you're updating the first array in the tuple or the last array in the tuple, it's still the same opcode cost. It's pretty expensive. It's almost like 100 ops, but it's the same regardless of what your data structure looks like. And so the idea was that I don't want developers to have to worry about, where certain arrays are in their data structure. But, just recently I've been thinking about it more. Maybe that's not the best approach, and maybe I should have TealScript be less opinionated and just try to work on developer education, compiler warnings, things like that, for when you're working with more complex types. So there's a lot of intricacies of the ABI that in order to be a really effective developer, you kind of have to be familiar with. So writing an abstracted language that tries to hide that from the end user, there's certainly a lot of challenges with that.
I mean, at the end of the day, can you just open the PR and assign Sylvia for a review?
Yeah. The alternative is just come up with a whole new API scheme. So.
And would you say this is something that folks are considering for the next batch of refinements for ABI, or this is still something that is rather like an independent proposal coming from the foundation side?
Yeah, I mean, this was still like the ABI was really just designed to efficiently pass in arguments. But, and talking to some of the researchers over at the Inc., when you talk about these things like iterating over arrays and modifying arrays, their response is, well, ABI types aren't really designed to be used during runtime. But the reality is that if you have that type coming in as an input, developers are just, inherently going to use that during runtime. And so there's been discussions on maybe coming up with like different encoding during runtime, or also maybe like, I personally think there are some changes that could be made to the ABI to make it a little bit more write efficient without sacrificing, the size and read efficiency as well. So it's certainly an ongoing discussion. I think one of the problems, though, is that because it doesn't have super great support in PyTEAL and Beaker, which have been two primary languages that developers are writing in, most developers haven't really worked with these super complex types yet. So it's we really kind of have to think ahead and try to think of, well, what may developers do in the future versus listening to developer feedback. Because right now, I mean, to be honest, a lot of production applications on Algorand, they're either not following the ABI at all, or they're not even using like PyTEAL or Beaker. They're just writing their low level languages. Or in the case of like Hippo, they're making their own damn language to do what they want to do, right? So I think it's still very early and it's still tough to really figure out like what do people really want to do with it. So I think part of this process is just going to be trying different things, seeing what connects most with developers, and then just being open to developer feedback and implementing those changes.
I will make a nice remark at the end of the episode, but some people are also concerned saying that, oh, there's, not market, but tooling fragmentation. There's too many things doing the same thing. But I mean, I don't think there's ever going to be a single set of software engineers who are satisfied with one particular stack or one particular language. I mean, a variety of tools in an environment where people are still trying to figure out what tools are going to be used isn't necessarily a bad thing. It's just a matter of time until you start seeing which one of those are actually getting more and more uses and adoption. And some of those could also be, I would say, marketed for different target audiences, right? You have, if you take, for example, a space of, libraries for backend services in Python, right? You have Flask, which is a very specific target auditory, very lightweight backend servers. Then you have Fast API, then you have Django, which is more enterprise in this case. And I believe something like that might happen with smart contracts and Algorand as well, right? The more stakes you have, I guess, the lower you go. But if it's a small, voting app or some fun little open source game that you have, or something that doesn't require a lot of very, everything requires a smart contract audit, ideally, I would say. But, if you're just making something for fun or something like that, it's having access to something high level that doesn't necessarily force you to go through a lot of different low level hoops to achieve your goal isn't a bad thing. It's just a matter of preference, ideally.
And I think it's certainly true that it's pretty fragmented right now. I think the main reason that happened is because the inks and the from the engineering side, but also from like the DevRel education side, the focus, especially like early on in the smart contract lifecycle, was always TEAL. And PyTEAL was pitched as like just a more convenient way to write TEAL. And I think that approach, being able to see now, there's all these people that have a deep understanding of how TEAL and the AVM works. I think that puts like the pool of Algorand developers in a pretty unique position where like there are a lot of developers on Algorand. I would say probably most developers that are actively building on Algorand now have at least some understanding of how like the AVM itself works and how TEAL works, just because the reality is that you kind of have to in order to be efficient to develop on Algorand right now, which has its negatives, right? The more developer friction, but the positive of that is that the developer experience of TEAL is really fantastic for what it is. I mean, it's hard to make any low-level machine language fun to write in, but TEAL is pretty good, especially if you compare this to like Ethereum or Solana. How many people are actually writing bytecode for EVM Solana contracts, right? Probably close to zero. And I think having that low-level language that all of our early adopters and early developers understand, allow them to participate in the building of the ecosystem. You have people like Fergo and Hippo that really understand, what these low-level languages are doing. And I watched, Fergal on your podcast earlier, and he was saying that he had a good understanding of this low level, and that's kind of what led him to Algorand and building Tealish. That's the kind of developers that having really good TEAL support for early on attracts. And I think that's really good for an early ecosystem. And so now the question is, okay, so we have all these, really good developers that understand, the AVM and TEAL. How do we build on top of that and attract kind of the next, generation, the next wave of developers? So I think it certainly is fragmented, and it's because of that, real focus on TEAL support early on. But I don't necessarily think that's a bad thing. And I think in general, like we're even counting like all crypto ecosystems, we're still very early in the space in terms of like developer maturity and dev tooling maturity and stuff like that. So I think personally, I think Algorand's in a really good position where we're not stuck to any one language. Like, I mean, there are other EVM languages like Viper and stuff, but everyone just knows Solidity, and that's kind of the EVM language. Where Algorand, it still has a lot of room to grow, and there's still room for that the best language for smart contract development to kind of emerge on Algorand, which I think puts it in a unique perspective, and it's why I love this space and why I love working on these tools, because there's all that potential there, and all that really smart people like Fergal, or even Frank, who's working on the C# libraries and C# smart contracts, which is, like you said, targeting different audiences. If you're like a Unity game dev that only works in C#, you can now write a smart contract in C#. Like, that's sick, and you can't really say the same thing for other smart contract platforms. So yeah, it definitely is a little bit fragmented, and it can be frustrating. But I think in the long term, we're going to look back on this and say like, wow, this was a really cool couple of years in Algorand when all these tools were developing.
Speaking of Frank, I certainly should get him on the podcast as well. I know Ras Fustino has been speaking very highly of him, and yeah, it would be interesting to talk about the stuff he's doing with Visual Studio. And once again, I completely agree on your point with in regards to the fragmentation. I think the only thing that is missing is basically just, none of those particular language frameworks necessarily directly compete with each other. But I think what's missing is a single nicely documented entry point where you could basically at the single glimpse have like a bird's eye view into everything that produces Teal code in every single language you want, and highlighting their pros and cons, like some sort of comparison. Okay, you can do this and this, you can do this and this, and basically having all of them as templates optional in AlgoKit. So basically you start from AlgoKit, a recommended entry point for developing smart contracts by Algorand Foundation. You start from there, you open up templates, and then you have some sort of, comparison table, and you evaluate yourself what suits your needs better given the current state of development of all of those different things. And I think that way you can streamline a lot more realistic feedback from people who actually may need that particular language for their project. And luckily, there's all of the prerequisites are there already, right? There's support for templates in AlgoKit, things like that. So hopefully there will be a bit more sort of marketing and defining of the target audiences of like, who are you trying to capture with this particular transpilation project.
Yeah. And that, John Woods, our CTO, like my first ever conversation with him was basically him saying exactly that. And we refer to it as like, what's the blessed path for Algorand development, where we want to say, oh, you're a new developer, go to this page. This will show you what languages you can use. These are the ones we recommend. But if you're a C# dev, you can also go over here. If you like low level stuff, you can go over here. And so making that the overall developer journey really clear is something that we're missing right now, and that's one of the downsides of fragmentation, like you mentioned. I do want to mention though, where I think we're closer to that than some people might think. One of the goals that AlgoKit has played a role in is like by the end of the year or maybe next year, we have a language that natively support a native Python language and maybe a native TypeScript language like TEALScript for writing contracts, and then tight integration into AlgoKit. So the blessed path is now, okay, if you're a developer, here's the tooling that you need. AlgoKit, which language do you want to use? Do you prefer Python or TypeScript? And then you kind of go that way. But then also, I think languages like Tealish, for example, the way I see it is that native support for Python and TypeScript are kind of the high level. These are your entry points into Algorand development. And then the way I see it is that TEALScript or Tealish kind of becomes a low-level language and kind of replaces the need to develop directly on Teal. And then you have all these, side paths where you have C#, and then I also know Drag MZ from our Discord is also working on like a C. I think it's like a C kind of interpreter kind of thing. Yes, Seal. Yes, yeah. So I think it'll always be true that there's never just one way to develop on Algorand, but really the goal, like you mentioned, is to have kind of the recommended way and then make it very clear what are the other alternatives and why might you choose those over this. And so, that's for at least the next year, definitely under, John and my whole DevRel team and just the CTO office in general, we're really focusing on the overall developer journey. And, first step of that is working on the tooling and the languages. So, that's hopefully, a year from now, we'll still have all these great languages, but the actual official path will be a little bit more clear. Nice.
And interesting remark in regards to potentially having Tealish as basically a drop-in replacement for like raw Teal code. Before we dive in, and sorry, I know we went a bit on a tangent, a little bit over time, but one particular question in regards to still the point was the comparison between the different languages. Is there any sort of comparison table or some sort of benchmark evaluating which transpiled Teal code is the most readable if you take Tealish, Beaker, and TealScript? Because I guess smart contract audits, to make it the life of the consulting firms who make the audits a bit easier, it's important to make a very readable and artifact in Teal. And I'm just curious which one is the most, or provides a lot of effort in this regard.
Yeah, so I can't speak much for Tealish in terms of emitted Teal, because I unfortunately haven't played around with Tealish a lot, because I've mostly been focusing on TealScript, because it's my own personal project, and then Beaker, because that's what we teach in like our boot camps and hackathons and stuff. So can't really talk too much about Tealish in terms of like the emitted Teal, but I know for like TealScript, that was certainly like a really big goal, is to improve what the emitted Teal looks like, because I think the emitted PyTEAL PyTEAL Teal is really hard to follow. And I think it's that way because there are some areas where PyTEAL tries to like optimize certain aspects of the code, and it also tries to make it a little bit more similar to what like the decompiled Teal. So for those that don't know, basically when you have your Teal source code and then you send that to a node to compile it, and then that thing that the node compiles is ultimately what lives on chain. So the on chain Teal that you see on like an Explorer isn't an exact one-to-one copy of the original Teal source code that was uploaded. So I think PyTEAL more closely resembles the decompiled Teal, but that also means it's a lot less readable. And to me, like I mentioned earlier, I think language comprehension is something that's not talked about enough in this space, and that I think should be made a lot more clear. So that was a focus for TealScript, and how it works on TealScript. And you can actually, if you go to the TealScript repo, so github.com/AlgorandDevRel/TealScript, there's an examples directory. And there are some, like one example is there's an AMM that was written in Beaker, so like PyTEAL generated Teal, and then one that was written in TealScript. And if you look at the two, the kind of main big difference of TealScript is that it has a much more liberal use of comments. And there's kind of two ways this plays in. So first, on TealScript, for kind of every chunk of logical code, it adds in a comment saying where this Teal code was generated from. So like which line of code in the TypeScript that it came from, and then also a copy of that code. So for example, if you have some assertion, like, is this number bigger than this number? Before you actually get to the teal logic, there'll be a comment that says, this is an assertion from this line. This is what the TypeScript line looks like. And then it'll show, look, this number, that number greater than assert in the teal. And really, the goal is to make it very clear when, like, where certain things in the teal are coming from based on the TypeScript. And PyTEAL by default doesn't offer this. Very recently, like in the last week or two, there was source mapping support in PyTEAL. Yeah, so that does help a little bit in that regard, but so the general layout of the teal can still be a little bit hard to follow. So that's really been a big focus for TEALScript, is being able to make it very easy. And also, as someone like so if I'm writing a new contract for a sender or something, I'll use TEALScript because it really helps the development process when you have a very clear mapping of the source to the teal, because the SDKs, the chain itself, the AlgoD, all it knows is teal. So it's going to throw you a teal line number and a program counter, and then you have to work backwards from that to figure out where it really came from. So not only is it more readable, which is better for comprehension, but also having it more readable makes it a lot easier during the development, where you can really pinpoint, where these errors are coming from, why they're happening a lot quicker. And so that's kind of been one of the primary focuses of TEALScript, is making sure that not only the original source code is readable, but the teal that is generated is also readable.
I was just looking at the split screen, seeing two artifacts from Tealish and TEALScript. I might say it's pretty similar, actually.
Oh, cool!
Kudos to you, man. You did a great job as because the end goal with Teal itself is having it readable and very structured is also very important to have. So
no,
it's great to see that it's also one of the things that you get out of the box, basically. And just to outline as well, I suppose, say similar to Tealish, the way you approach support for different teal versions is by relying on the lang spec from the main Algorand implementation repo. Yep. So it's sort of like agnostic, right? So the versions, if there's a new version, it's a matter of updating the lang spec and then adding the necessarily methods abstractions to support new functionality, right?
Yes, there is kind of an asterisk on that, and that's because there's kind of two kind of components to TEALScript. There's the actual compiler itself, which just reads the code and then generates the teal, but then there's also all this kind of extra typing that exists solely for the purpose of support in the IDE. Mm-hmm. So what the lang spec is used for is used at the compiler level. So if there's a new opcode, you can add it to your TEALScript file, update the lang spec, and it will compile no problem. But in the IDE, if you try to use that opcode, it'll have the red squiggly underline saying, I don't know what this is, because right now, all of that TypeScript typing basically is manually generated. But there's no reason I couldn't have, especially because Ben or Barnji is working on a new format for the lang spec where it's even more descriptive, where basically that the TypeScript and all the types itself are also auto-generated from the lang spec. But right now, that's just kind of manually maintained by myself. But yeah, the compiler itself is completely dynamic based on the lang spec.
And I'm just curious, is the lang spec thing, is it based on some open source standard, some RFC, or it's literally just a formal, JSON schema that was designed specifically for AVM? Because I've seen the term used in many different languages. I was just not sure if it's following some sort of common schema in this regard, or it's
really, I mean, as far as I know, it's kind of just our own arbitrary schema that we came up with. And then, like I mentioned, Ben or Barnji from Discord, he's working on updating it. And like to me, as a language developer, kind of the main one of the really nice things about the new format will be it'll have kind of more descriptive types. So, for example, like if you have some teal opcode that returns an address in the current lang spec, it doesn't specify that's an address. It just says, bytes, UN64. Whereas the new lang spec will specify if it's an address, if it's an app ID, asset ID, which greatly helps higher level languages have like that auto-generated code. So, yeah. So, and the reason I did that is because I saw, Fergal's talking to Cypher where he said that he auto-generated off the lang spec. And I was like, well, that's genius. I'm going to do that too. And by the way, just a side note, TealScript actually started in Decipher after I saw Fergal's talk. For a while, I realized that Ruby probably wasn't the right path, but I really wasn't sure what I wanted to do. And then seeing Fergal's talk was like, okay, maybe I could do something similar in TypeScript. So at like 3 a.m., I couldn't sleep because I was like jet lagged and the time difference. I was like, maybe I'll just try to write a smart contract in TypeScript and see if I can get it working. And so that was the inception of
this. Were you in the keynote when the presentation was going? Because I was at the Decipher as well, and I think I saw you in the auditorium with the laptop that day. So I wonder if that was during the Fergal's speech happening, actually.
Yes, yeah. So, yeah, it wasn't until later that night where I actually started writing it, but I was definitely taking notes during Fergal's talk. And like I said, like I don't view TealScript and Tealish competing languages. I think there's ultimately different end goal designs, but a lot of what he's doing there, like stuff with the lang spec, I thought was really cool. So, yeah, definitely an inspiration.
Well, Fergal, if you're listening to this, here's another point towards Tealish. You've just inspired Joe to create something that potentially expands the ecosystem as well. So for the sake of time, I'll try to keep some of the remaining questions shorter because we pretty much covered a lot in regards to features, the functionality, some of the architecture. We covered how the lang spec is used. I guess one main thing in regards to the deep dive section for the TealScript, testing. Just curious, what would you say were the most challenging things in regards to testing the compiler, testing the type system for TealScript, and what were the lessons learned in this regard?
Yeah, I mean, so just for some background also, so my job prior to working for Algorand was an SQA engineer in the defense industry. So testing is something that I've thought about a lot, and it was something coming to TealScript. I knew as a developer, it's really easy to just kind of start building and be like, oh, I'll do the testing later. And then you end up with like spaghetti code that's completely untested. So this was also like something that was really important to me. It's still definitely not anywhere near where it needs to be. And also kind of related to testing is a lot of the error messages in TealScript are just blank because I haven't yet written the error messages out. But for testing itself, my initial kind of idea for testing was write tests that generate teal and then compare that teal to make sure that it's what I expect it to be. The problem with this is that it's kind of time consuming to manually write out all the teal that you expect to be emitted. And then B, if you make like a small change in terms of like, for instance, when I first started TealScript, it used scratch slots for local variables. So like your arguments or, any constants that you defined or any constants or variables you defined in your function, I use scratch variables, but then I switched it to use the frame pointer.
Mhm.
So now like the code still functions the same, but all the generated teal, it changed from, load to frame did.
Mm.
And so changes like that were kind of annoying to deal with. And I think ultimately you do want that kind of sort of, gold file verification in a testing system, but the development of that can be kind of slow. So, Ben, he implemented, since he developed Beaker TS, he implemented the app spec export functionality into TealScript. So now it made it really easy to do full end-to-end testing. And now recently in all my tests, so like as I was developing out the ADI, for example, what I'm doing for all my testing right now is just full end-to-end testing. So basically I write the contract, then the test will compile it, and then use the Beaker TS generated client to call it on chain and basically either do the assertion on chain or return a value from the ABI method and assert that it's the array I expected, the type I expected, whatever. And that's been super useful because to our existing tooling, so like the Atomic Transaction Composer and like our SDK, it already has in error handling for if like a big problem that I kept running into was not properly encoding arrays. So as I mentioned, there's kind of a lot of things to think about in terms of like offsets and what values need to be updated when you're changing arrays. So having end-to-end testing for this, that just made sure this is the array that I expect to be outputted, insert that in my test, and if it passes, then I know I'm good. Made it a lot easier than trying to write out, the 100 lines of teal that I expect to be emitted. And so focusing on end-to-end testing first has been really helpful. And also, I think that's kind of the most important testing for developers, is making sure that it works. If there's a recent bug that there's an extra, sometimes in the teal generated code, I'd write dupe n 0. And what the dupe n opcode is duplicate the previous stack value some number of times. But so dupe n 0 does effectively nothing. But having that in my code doesn't hurt functionality. It's something that I can kind of like scrape out later. And so just focusing on the core end-to-end functionality first has been my mindset. And I think it's helped me develop really quickly.
Awesome response. And I guess you can't get away too far with mocks in smart contract testing anyway. Also notice that, and this is really just off topic, but is running sandbox in GitHub Action Worker faster if you do git clone and then do sandbox app, or it's faster to just do pipex AlgoKit localnet start?
Yes, so it actually is faster to do AlgoKit. But the reason I originally was using AlgoKit in my CI, but I had to switch to Sandbox because in a Algorand Genesis file, so like the file that tells the network what it should generate as, there's an option for the rewards pool. And if this value of the rewards pool isn't 0, that means accounts on the network will get rewards, much like the rewards that existed on mainnet when Algorand was first created.
Mm-hmm.
But this is really problematic when you have test assertions based on account balances, because at some point the rewards will kick in, which basically makes it look like you just got algo out of nowhere. And so on Sandbox, that's currently disabled, but we found out that wasn't actually disabled yet on AlgoKit. Now, luckily, this is just a trivial update the JSON file, and I did make a PR for it. I can't remember if it's been merged yet or not. But yeah, so that's why I'm using Sandbox right now. Eventually, AlgoKit will be quicker because it uses so Sandbox builds AlgoD and indexer from source, and AlgoKit just pulls in pre-built images from Docker. So it's what I would prefer to use, but because of the reward balance issue, I'm still using Sandbox.
I see. All right, then. So I guess let's move on to the outro part of the episode. We've covered a lot of interesting topics. I'd say from my side, and hopefully for the listeners, it's now absolutely clear in regards to, you know, where you define the clear separation in between what's the sort of the strongest points in regards to TealScript versus Beaker versus PyTEAL versus Tealish. Once again, a lot of them pretty much can coexist without a lot of friction. It's a matter of preference, a matter of which tool basically will get the most use eventually. In your opinion, what is the biggest set of challenges that Algorand is currently facing? You can touch on either dev-related aspects or not. It's up to you. And what do you think is the best approach, or at least, in your opinion, the best approach to, you know, tackle these challenges?
Yeah, I mean, I think the biggest challenge that applies to Algorand, but pretty much any non-EVM chain, is that right now, I think the way crypto is being used is very different from how it'll be actually used in like 5 years from now, where right now everyone really just cares about like DeFi, making your TVL higher, making your market cap higher. And obviously DeFi is incredibly important for any blockchain. But I think there's kind of this like culture in crypto where new developers get into it because they want to make something that holds a lot of money, that has big numbers, that can make them a lot of money. And the easiest way to do that is copying and pasting Solidity code. And I think for any, you know, non-EVM smart contract platform, it's a really big challenge. And it's why, like, you see these amazing developments like, you know, ZK rollups that are bending over backwards to support EVM, just because it's dominating the space right now. But I think ultimately what will play out better in the long run is these environments like the AVM that is just more, you know, as John always says, fit for purpose. And I think Algorand really is uniquely positioned where it is really usable for like a lot of use cases where you don't have forks, you don't have really long block times, you have instant finality, and you know those features, along with the fact that Algorand is really uniquely positioned in terms of AVM node architecture design to scale in a decentralized manner. I think focusing on those principles in the long term is ultimately what's going to lead to the success or, you know, demise of crypto projects. And I think it's very similar to, you know, one comparison I like making is ARM versus x86, where you saw very recently, like in the past couple of years, Apple has made ARM like mainstream with Apple Silicon. And the reason they were able to do that is because they made the user experience for both developers and end users seamless when you're switching from, you know, Intel x86 to you know, ARM.
Mm-hmm.
And they did that, you know, they were uniquely positioned because they had Swift and this very tight developer ecosystem.
They had like 7 years of testing it on their mobile devices already.
Right.
They're perfecting it on the Apple chips for iPhones, iPads, and yeah.
Yeah. And they were able to make that transition as seamless as possible. And I think, you know, you saw Windows, they've had ARM devices like Windows 10 ARM edition or whatever it's called for many years before Apple came out, but it never got adoption because Windows, one of the paradigms of Windows is to bend over backwards to make everything backwards compatible. And I think that sort of development environment, it can get really disrupted when you just have that one breaking point moment. And I think making that transition from Web 2 to Web 3 more seamless and making, you know, once we have that kind of nailed down, that transition from Web 2 to AVM or developers that would traditionally gravitate towards Solidity now want to gravitate towards the AVM. I think that will be the solution to that problem in terms of, how do we attract developers? Because I think, Algorand, like I said, it's uniquely positioned. We're seeing a lot of unique projects that are real world solutions that you aren't seeing on other chains. So it's like, okay, we have this great technology. It's clearly better, like in the same way that ARM, like clearly better for mobile devices in particular. But how do we make adoption actually happen? And I think it's just a matter of that seamless transition, and then there'll be an inflection point eventually, and that's what will really need to happen in order to see like mass adoption of crypto, in my opinion.
Great point. Yeah, I would say that it's also a matter of like speaking on the very simple terms. I feel like the real transition from Web 2 to Web 3 is going to happen when people will stop calling it Web 2 and Web 3. And,
I just will say that I think I kind of hate the fact that crypto has like co-opted the term Web 3. To me, because right now it's pretty much just a marketing gimmick. But to me, what Web 3 really is about is decentralized web. And crypto is not the only piece, and far from being the most important piece. There's also other technologies like Wasm that, as you're starting to see more develop, like as soon as we get WASI sockets and you can do full decentralized networking in your front end with like higher level languages like Rust or Ruby, then you can maybe move towards these more like serverless websites and like these more interesting decentralized design patterns. And that's where crypto can really lend itself to. Right now, Web3, I think, is mostly blockchain shoehorned into, traditional Web2 solutions. That's not to say like, there are some, what I would consider like Web3 solutions that are really cool, but also I think there's way more pieces to the puzzle of Web3 than just crypto. And as we see more technology advancements, it'll be more clear for like crypto use cases. Like AI is a good example of that as well, of just all these different technologies contributing to the next generation of web and not just, crypto.
Yeah, I feel like there's certainly a lot of interesting applications in AI as well that blockchain can benefit from, especially on the side of ownership and identity management. At some point, there would need to be some guardrails to, safeguard people from just being faked and making fake voices, fake audio formats. And you can imagine the stuff that will start happening once there will be GPT-enabled viruses, and social engineering will become just a breeze for hackers. It already is, I think. But anyway, not to put a lot of AI into this conversation. I guess let's move on to one of the questions that I basically ask to all of my guests at the end of the podcast. What advice would you give for folks who pretty much have engineering background, have some software engineering background experience, but would like to try blockchain development, would like to try distributed systems and things like Algorand in general?
Yeah, I mean, I think my number one advice is that kind of what we were talking about earlier is having that low level understanding. I think in general, and for Algorand in particular, that's still very essential, even if we have languages like TEALScript that abstract away a lot of that low level stuff. And I think that's just because the understanding the unique constraints that you're working with in smart contracts is a very different mindset. And, if I could, say one thing that could burn into every smart contract developer's head, it's, do off-chain, verify on-chain. And that paradigm of figuring out like, what do I really need to put on-chain and what can I use other solutions for? And a common example I like to give, as earlier we were talking about like arrays and optimizing them, is let's say you have some array and you want to delete some value in it. The kind of Web 2 traditional approach is iterate over every single value in the array until that value is reached and then delete it. But in a smart contract, it makes way more sense to give that specific value what index that value is at, verify that's actually the value you're deleting, and then delete it. So not doing that on-chain iteration. And it's the same thing for like files, right? Using technologies like IPFS, SIA, Filecoin, thinking about just what really is the best technology to do this thing. As we were talking about Web3, it's very easy to shoehorn smart contracts into places that they don't really serve a purpose. So really thinking about like, what are the problems of using smart contracts in general that's solving, and also like, how do I represent this data on chain? And just really thinking about like data structures and overall architecture is super crucial whenever you're working with like a low level system, whether it's, abstracted in an AVM or EVM environment, or if you're working with like direct hardware. Just thinking about those constraints and really optimizing for that is kind of where you need to be at. So my recommendation is to not, as a new developer, not focus so much on the language and development itself, but also really understanding the environment, what your resources and constraints, and really just understanding the problems that you're really trying to solve, because it's really important, especially if you have immutable smart contracts, that it's well thought out and that you're doing things as efficiently as possible.
Very, very well thought out response. Thanks for that, Joe. I'm sure listeners will find this very useful. And I guess on that note, thank you for everyone who stayed with us this long. Once again, this is usually something that the most dedicated listeners are reaching. So thanks for being an amazing guest. Thanks for basically creating TEALScript. This is the only high-level transpilation language in the entire Algorand ecosystem as of now that allows you to do raw TypeScript Algorand Smart Contract development, and I think this is pretty cool. With that, thanks to everyone who listened to this episode, and I look forward to discuss some more interesting stuff. What I was actually thinking is, if there's going to be a next major AVM release or something like that, I was thinking if we could do like some sort of joint episode to have Fergal and yourself and maybe some other creators like Barnji, and just have this sort of maybe debate or a forum on different feedback points that you may have in regards to specifically AVM stuff that folks I think can listen to, basically, because folks like yourself and Fergal would be representing a very specific niche of TEAL development, and I think that feedback might be very useful to get in this interactive format. So
yeah, definitely. Yeah, that would be really cool. Yeah, I mean, especially the next update for AVM will be including shared resources, which is a pretty big paradigm shift from how we currently handle resources from like just the AVM, point of view, but also the like ABI developer. How do I think about what my resources are, like I was just mentioning? So yeah, it'll be a big release. So I'd love to talk more about it.